This is a video based upon derivatives past paper questions for 100 marks. So we shall try to solve these questions now, starting from the first question, which is from paper 1, and it is for 16 marks. So now it states the following diagram shows the graph y equals to 4 minus x square, x lies between 0 to 2, and a rectangle ORST. The rectangle has a vertex at origin. The vertex on y-axis is r, which is 0, y. Vertex on x-axis, which is t, x, 0, and a vertex s, x, y on the graph. Then let P represent the perimeter. So we are going to talking about the perimeter of the rectangle ORST. Show that perimeter equals to minus 2x square plus 2x plus 8. That is being asked. So perimeter will be 2 times of x plus 2 times of y. 2x plus 2y. That's going to be the perimeter. Now 2x remains as 2x. But what is y? We know that y is 4 minus x square. So 2 times of 4 minus x square. So it becomes 2x plus 8 minus 2x square, which is being rearranged and written as negative 2x square plus 2x plus 8. Find the dimensions of the rectangle ORST that has maximum perimeter and determine the value of the maximum. Now, so first one, whenever the maximum means the first derivative should be equals to 0. So negative 4x plus 2 should be equals to 0, which gives me the value of x as half. Now substitute this value of x in y equals to 4 minus x square. So y equals to 4 minus x square, which is 4 minus 1 upon 2 whole square, which becomes 15 upon 4. So I got the value as 15 upon 4. The dimensions are x equals to 1 upon 2. He's asking what are the dimensions. X is 1 upon 2 and y is 15 upon 4 are the dimensions. Next, is he asking find the determine the value of the maximum perimeter. So which is going to be 2x plus 2y, which is 2 times of 1 upon 2 plus 2 times of 15 upon 4, which is going to be 17 upon 2. So that's going to be the maximum perimeter. Next question, let A represents the area of the rectangle ORST. Find an expression of A in terms of x. So area equals to xy, so which is x times 4 minus x square, which is 4x minus x cube. Find the dimensions of the rectangle ORST that has maximum area. So dA upon dx should be equals to 4 minus 3x square. Now for maximum or minimum, the first derivative should be equals to 0. So 4 minus 3x square equals to 0. So x square equals to 4 upon 3, x square equals to 4 upon 3, x equals to 2 upon square root 3. I take only positive because it should be only x value can be positive, negative is not possible at all. Now substitute to get the value of y, which is 4 minus 2 upon square root 3 whole square, so which gives me 8 upon 3. He's just asking only the dimensions, not the area. Then find the maximum area over here. Maximum area will be xy, which is 16 upon 3 root 3. That's going to be the answer. Now coming to question number 2, which is from paper 2. A manufacturer makes trash cans in the form of a cylinder with a hemispherical top. The trash has a height of 70 centimeters. The base radius is 20. The base radius of both cylinder and hemispherical is 20. Write down the height of the cylinder. So this is 20. So the height of the cylindrical part will be 70 minus 20, which is going to be 50. Then that's answer. Then find the volume of the cylinder. So volume of the cylinder, volume of the trash can. So which is volume of the cylinder pi r square h plus 1 upon 2 times, because it is semicircle, 4 by 3 pi r cube. 4 by 3 pi r cube. So let me write it out the formula over here. The formula is pi r square h plus 4 upon 3 pi r cube. I use that formula. Then I'm directly writing it out the answer. 79,600 centimeter cube is going to be the answer. Now, a designer is asked to produce a new trash can. A new trash can will also be in the form of a cylinder with hemispherical top. This trash can will have a height of h centimeters and the base radius of r centimeters. There, the design constraint such that h plus 2r equals to 110. The designer has to maximize the volume of the trash can, find the height of the cylinder of the new trash can in terms of h. So, what has been given? H plus 2r equals to 110. So we want volume of the trash can. Find the height of the cylinder. Height of the cylinder is total height minus r. Total height minus r. Now, but capital H is from here. What is the capital H value from here? Capital H is 110 minus 2r. So I plug in that one over here. 110 minus 2r minus r. So which is equals to 110 minus 3r. Show that the volume V is given by 110 pi r cube. So volume is given by 2 upon 3 pi r cube plus pi r square h. Pi r square h is 100 minus 3r. So when I simplify that one, I'll be getting 2 upon 3 pi r cube plus 100 pi r square minus 3 pi r cube. Simplify that, we should be getting 100 pi r square minus 7 upon 3 pi r cube. Using your graphing display calculator, find the value of r that will maximize. So you just need to use the GDC, no need of derivative and so on. You should be getting that graph and find the maximum point. R value should be equals to 31.4 centimeters. So draw the graph on the graphing calculator and you will be getting the value of r as 31.4 centimeters. The designer claims that the new trash can has a capacity that is at least 40% greater than the capacity of the original trash can. Since whether the designer claim is true or false. So then what is the thing? We know we have to find the volume. So the volume is, we have derived the formula for the volume. So volume was 110 pi r cube. R is 31.4. 285, take full calculator display whole cube minus 7 upon 3 pi r cube, 31.4825 whole cube. Simplify that, you should be able to get that answer. So then I will be simplifying it out. Then volume, then simplify it out, you should be getting that answer, which is 111 114,000. That's going to be the answer. So he is asking, designer claims that the new trash can has a capacity that is at least 40% greater than the capacity of the original trash can. State whether the designer's claim is correct or justify your answer. So first of all, I find it out the volume by using the formula 110 pi r cube minus 7 by 3 pi r cube, and I got that answer as 114,000. Now, so what is the increase in the capacity? Increase in capacity will be 113 113.781 minus 79587.0 divided by 79587.0 times 100. So which comes nothing but what? 43%. So is obviously it is greater than 40%. So that's going to be the answer. If at all you don't want to do in that way, another way is 40% more is 1.40 times 79,587, which gives you 114,000, 111,421.81. So that's going to be the answer. Then we'll go to the next question. We have done the justified that answer. So we can write it as that the claim is correct. Question number 3. Let f of x equals to x cube minus 2x square plus ax plus 6. Part of the graph f is shown in the following diagram. Find f prime x. F prime x is going to be very simple, which is 3x square minus 4x plus a. Hence find the equation of L in terms of a. What is L? L is the tangent to the graph at P. So what is the value of x? X value is 0. X value is 0. And what is will be the y value? Y value will be 6, 0 comma 6. Then what am I doing it out? I am finding f prime 0. F prime 0 will be 3 times of 0 whole square minus 4 times of 0 plus a plus a. So what's going to be the gradient? Gradient is going to be the a. Then the equation will be y minus y1 equals to m times x minus x1. So y equals to ax plus 6. That's going to be the equation. I have found it out in terms of a. The graph of f has a local minimum point at a q. The line L passes through q. So for that, f of x should be equals to L. X cube minus 2x square plus ax plus 6 should be equals to ax plus 6. Now ax plus 6 gets cancels. X cube minus 2x square should be equals to 0. Then take x square common, x minus 2 equals to 0. So either x equals to 0 or x equals to 2. So I got the value of x equals to 2. This is at q. X equals to 2 at q. Now I need to get the value of a. So at q also, what will happen is, now we have to find the value of q. So let me write it out all this over there rather than writing out over here so that I have a lot of space. So f prime, what is that? F of x. F of x should be equals to L. So x cube minus 2x square plus ax plus 6 should be equals to ax plus 6, which gives me x cube minus 2x square equals to 0. X square common, x minus 2 equals to 0. So x is equals to 2 at q. So I got the value of x at q. Now f prime f prime x equals to 0. So because at the minimum point f prime x should be equals to 0. So 3x square minus 4x plus a equals to 0. But x is 2, right? So 3 times 2 square minus 4 times 2 plus a equals to 0. This gives me a value as negative 4. Question number 4. Anuka has an eco-friendly bag in the shape of a cuboid with a width 12 centimeters and a length 36 centimeters and a height 9 centimeters. The bag is made from 5 rectangular pieces cloth and is open at the top. Calculate the area of the cloth. So area of the cloth will be 36 times 12, which is the base. Then on the left side and right side 9 times 12, and on the front and the back it will be 2 times 9 times 36. So simplify that, you should be able to get 1300 centimeters square. Then calculate the volume. Volume is very simple, 36 times 9 times 12, which is 3890 centimeter cube. Then the width of the Nanoco's bag is x centimeters, its length is 3 times its width, and the height is y centimeters. So it is given over here. The volume of the Nanoco's bag is 3888. Use this value to write down and simplify the equation in terms of x and y, the volume of the Nanoco's bag. So 3x times y equals to 3888. So we'll be getting x square y equals to 1296. Next, I want y equals to 1296 by x square. Write down and simplify an expression in terms of x and y, the area of the cloth. So area of the cloth will be 3x square, then 2 times of xy, then 2 times of 3xy, which is going to be 3x square plus 8xy. Next, use your answers in part C and B to show that. So area equals to 3x square plus 8x times y, which is 1296 divided by x square. Simplify that, you should be getting it out 3x square plus 10368 divided by x. Find dA by dx. dA by dx will become 6x minus 10368 divided by x square. Use your answer in part F to show that the width of the Nanuka's bag is this much. So the first derivative should be equals to 0. 10368 upon x square should be equals to 0. So what does that becomes? 6x cube equals to 10368. So x cube equals to 1728. So x equals to cube root of 1728, which is nothing but what? 12 centimeters. Then Hungmin designs a concrete bird path. The bird path is supported by a pedestal. This is shown in the diagram. The interior of the bird path is in the shape of a cone and a radius r, a height h, and a constant slanting height 50. Write down the equation of r and h. So we know that Pythagoras theorem, h square plus r square equals to 50 square equals to 50 square. So what's going to be r square? R square equals to 2500 minus h square. R equals to square root of 2500 minus h square. Let V be the volume of the bird path. Show that. So volume is 1 upon 3 pi r square. R square is this one times h. So it's going to be 1 upon 3 pi times 2500 h minus h cube. Expand it out, it becomes 2500 pi h upon 3 minus 1 upon 3 pi h cube. That's going to be the answer. Find dV by dH. Second part D. This one I will have done it out over here. So I will copy that one there and bring it over here. I have proved it. Find dV by dH. dV by dH is 2500 pi upon 3 minus pi h square. That is dV by dH. Now using your answer in part C, find the maximum value. So 2500 pi upon 3 minus pi h square should be equals to 0. So which you can use the calculator to get that value of GDC to get h equals to 28.9. Or you can use basic calculations also, 28.9 centimeter square. Centimeter. Find the maximum. So V equals to 2500 times pi times 28.8675. You should take the full calculator display by 3 minus pi times 28.8675 whole square divided by 3. Simplify that, you should be able to get that answer as 50,400 centimeter cube. Part F. To prevent the leaks, a sealant is applied to the interior surface of the bird bath. Find the surface area to be covered by the sealant given that the bird bath has maximum. So, surface area is pi RH, pi square root of 2500 minus 28.8675 whole square times 50. So, which is 6410 centimeters square. Two boats A and B travel due north. Initially, boat B is positioned at 50 meters due east of boat A. The distances traveled by boat A and boat B after t seconds are x meters and y meters respectively. The angle theta is the radian measure of the bearing of the boat B from boat A. This information is shown in the below. Show that x equals to this much. So, first of all, what am I going to do? Tan theta. Tan theta equals to 50 by y minus x. I am going to use tan theta. Where is the diagram over there? Tan theta is 50 upon y minus x. So this is theta. This is y minus x. Tan theta is 50 by y minus x. I write it out over there, 50 upon y minus x. So cross multiplication, or I want cot theta. So cot theta equals to y minus x upon 50. So y minus x equals to 50 cot theta. So y equals to x plus 50 cot theta. At time t, the following conditions are true. Boat B has traveled 10 meters. Boat B is traveling double the speed. The rate change of theta is minus 0.1. Find the speed of A. So, I am going to find dy by dt. dy by dt equals to dx upon dt minus 50. Cotangent theta is minus cosecant square theta d theta by dt. So, but dy by dt is 2 dx upon dt equals to dx upon dt minus 50 cosecant square theta d theta by dt. Now, what will happen now? So, 2 dx upon dt minus dx upon dt is dx upon dt is minus 50 cosecant square theta d theta by dt. So, now substitute the values. But what has been given? The rate change is 0.1. d theta by dt is minus 0.1. So, I want theta over there. So, how do I find it out theta? We know that tan theta equals to 5. So theta equals to tan inverse of 5. So which is 1.373. Or else tan inverse of 5. Then instead of that, if tan theta is 5, cot theta equals to 1 upon 5. We know the identity cosecant square theta minus cot square theta equals to 1. So cosecant square theta will be 1 plus cot square theta, which is 1 plus 1 upon 25, which is 26 upon 25. Now plugging in that values, so you'll be getting negative 50 times 26 upon 25 times negative 0.1, so which is going to be 5.2 meter. Though I get negative, I'm going to directly write that answer as positive. Then question number 7. A function f is defined f of x equals to this much. Find the values of p and q. So 4x square minus 1 should not be equals to 0, which can be written as 2x plus 1 times 2x minus 1 is not equals to 0. So x is not equals to negative 1 upon 2, x is not equal to positive 1 upon 2. So p is going to be plus 1 upon 2, q is negative 1 upon 2. Then find the expression of f prime x. So use the quotient rule. 4x square minus 1 whole square, 4x square minus 1 times 3 minus 8x times 3x plus 2. So which becomes negative, directly I am writing negative 12x square negative 6x minus 3 divided by 4x square minus 1 whole square. So that is the meaning. Then let y equal to f of x has exactly one point of inflection. Find the x coordinate of point of inflection. For x coordinate of point of inflection, what is the thing is f double prime x should be equals to 0. So by using the GDC, you can get the value of x as negative 1.60. Sketch the graph of y equal to f of x, showing the values of any x-intercepts, the coordinates of local maximum and minima, and the equations of the asymptotes. Just now, we got the equations of asymptotes were negative half and positive half. So, there is one asymptote at negative half and another asymptote at positive half. I'm just doing a rough graph. You should see that the spacing should be the same. Then, and at negative 1.60, we have a point of inflection at negative 1.6. We have a point of inflection over there, and we have a minimum point. Have we found it at a minimum point? We did not find the minimum point, and it is a paper 2 question, so you can use a graphing calculator to get that graph. So therefore, when you try to do it out by graphing calculator, it should be looking it out somewhere like this. Be careful over there. I'm giving you the approximate shape. This should be the shape, and don't forget to write the local maximum point 226 comma negative 1.66, and over here minimum point minus 1.11 comma minus 0.339. This is going to be the answer, and this is x equals to half and x equals to negative half, and this is x-axis and this is y-axis and the origin. Next, the function g is defined by g of x equals to this much. X is not equal to minus 2 upon 3. Find the equations of the all the asymptotes. So x equals to negative 2 upon 3 is one of the asymptote, and oblique asymptote, if you remember, 4 divided by 3. So the gradient, so we can do that, or else we will do by long division. 3x plus 2 divided by 4x square plus 0x minus 1. So it becomes 4 upon 3x. So multiply with 4 upon 3x, it becomes 4x square plus 8 upon 3x minus 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 8 upon 3x minus 1. So it's going to be minus 8 upon 9. So minus 8 upon 3x, then minus 16 upon 9. So when I simplify that, plus plus, so it becomes minus 8 upon 9 minus 16 upon 9, it becomes 7 upon 9 minus 7 upon 9 plus 7 upon 9. So what will be my oblique asymptote? My oblique asymptote is y equals to 4 upon 3x minus 8 upon 9 is going to be the oblique asymptote. By considering the graph y equal to f of x, g of x minus f of x, or otherwise solve f of x is less than g of x. So we will, by drawing the graph on the graphing calculator, you should be getting x value as negative 0.568729 and x value as 1.31872. So x lies between negative 2 upon 3 and negative 0.569, or else x lies between negative 0.5 to positive 0.5 and x is greater than 1.32. See that you should be getting it out all the three answers. That's why it is 4 marks question. That's all. I think so. That completes the paper. See you in the next video. Bye.